All right, so we're going to start section 3.2 now. 3.2 is called quadratic functions, and there's quite a lot of information here in this section that we're going to need to cover. So um, now the topic for the first 6 sections, as I said, was polynomials. A quadratic function is an example of a polynomial. Okay, it says that a quadratic equation is an equation of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not 0. Okay, so I'm in polynomial form, and I'm just adding up these 3 terms. And every single power of x is a whole number, right? And the coefficients, a, b, and c, those are real numbers. Okay? Now, there are 4 methods for solving a quadratic equation. They're factoring, which we have been there and done that before with factoring. Factoring, by the way, is by far and away the easiest method to solve a quadratic equation. Okay, now not all quadratics factor nicely, so there is more to know with this. But item 2 would be to use what's called the square root property. Item 3 would be to use the completing the square method. And then item 4 would be to use the quadratic formula. So let's take a look at this first example. Like, what if I had the equation 2x squared minus x equals 3? And I want to solve for x. So let's get everything onto the left. If I subtract 3 from both sides. And I just said factoring is by far and away the easiest method. Okay, this equation is going to factor nicely for us. So if I set up the factors of 2 are 2 and 1. The factors of 3 are 3 and 1. That's a negative 3 at the end. So I also know that the signs have to alternate positive, negative, or negative, positive. I'm trying to get a negative x in the middle. So if we factor this as 2x minus 3 times x plus 1, that should work, right? Because if I FOIL this back, I got 2x times x, that's 2x squared. The outer and the inner terms, we're looking at 2x minus 3x, that's negative x in the middle. And then negative 3 times 1 is negative 3 at the end. That looks good. Okay, so then I would set each factor equal to 0 and solve 2x minus 3 equals 0. Means that if I add 3 and divide by 2, x is 3 halves. X plus 1 equals 0 means that x is negative 1. So this is going to have 2 solutions to it. Okay, any quadratic equation that you solve will always have 2 solutions to it. Keep that in mind. That's very important. You'll always have 2 answers. Okay? So again, we have been there and done that before with factoring. Okay? The first thing that I always think of whenever I have any quadratic equation is to see if it factors. Okay? Let's take a look at the square root property next, and I'll show you some examples of that. So what if I wanted to solve the equation x minus 4 squared equals 12? That would be a quadratic equation because I can get that in quadratic form. I can get that in the form ax squared plus bx plus c equals 0. Now I'm not going to do that. Okay? Because I'm all set up to use the square root property. And if I take the square root of both sides, the square root of something squared would just be that something. So the square root of x minus 4 squared is x minus 4. In other words, the square root sign and the power of 2 kind of cancel each other out there. And on the right, I'm going to have the square root of 12. Now, whenever I take the square root of both sides in an equation, I always need to tack on a plus minus onto the right. Okay, so then I'm solving for x. So if I add 4 to both sides, x is equal to 4 plus or minus root 12. Root 12 breaks down as 2 root 3. Right? 4 times 3 is 12. So my answer will be 4 plus or minus 2 root 3, those 2 answers. be 4 plus 2 root 3, that's one answer. And then 4 minus 2 root 3, that's another answer. Okay. Now always keep the answers in exact form. Okay. There's no reason to go to the calculator and have some, have some infinite decimal. Okay. Those are not exact answers. So let's try another example here. What if we have 2x minus 3 squared equals 24? Okay, well, I see this power of 2, and I want to get rid of that. So let's go ahead and take the square root of both sides. And I have 2x plus 3, or 2x minus 3 on the left. And that is equal to plus or minus the square root of 24 on the right. Okay, now the square root of 24, that's 2 root 6, right? Because 4 times 6 is 24. The square root of 4 is 2. If I then add 3 to both sides, 2x would be equal to 3 plus or minus 2 root 6. And then divide by 2. So x would be equal to 3 plus or minus 2 root 6 all over 2. That would be the two answers. So I've got 3 plus 2 root 6 all over 2. That's one answer. And 3 minus 2 root 6 all over 2. That's the second answer. Okay, again, you always have two answers whenever you're solving a quadratic equation. And this would be an example of a quadratic equation. So if I wanted to, I could get this, this equation in the form ax squared plus bx plus c equals 0. All right. Now, the next thing is completing the square. So completing the square is, a bit kind of weird how it works. But let me just use this first example that we had done. We got 2x squared minus x minus 3 equals 0. And we already know the answers, right? It's x equals 3 halves and x equals negative 1. Okay, let me show you how to get those same answers, but this time by using the completing the square method. Okay, there's two things that always need to happen before you complete the square. The first thing is you need a 1 in front of the x squared term. Right now it's a 2. So I'm going to go ahead and divide both sides by 2. And I got x squared minus 1 half x minus 3 halves equals 0. The second thing is that I need to bring the constant over to the right. So I'm going to add 3 halves to both sides. And now I've got x squared minus 1 half x equals 3 halves. Okay, now those two things that I just said, getting the 1 in front of x squared and then bringing the constant over to the right, those two things are just the setup for completing the square. Like I haven't done any completing the square yet. Okay, but I'm all set up to do that now. So how I actually complete the square is I need to take a look at the number that's in front of x, it's negative 1 half, and I need to take half of that number squared. And I'm going to add that new number to both sides. Okay, so I said take half of the number in front of x squared, and then you're going to add that new number to both sides. Well, half of negative 1 half is negative 1/4. And if I square negative 1/4, I get 1/16. So 1/16 is going to be the magical number that we're going to have to add to both sides in the next line. Okay, and I've done that. Now the reason for doing that, because that sounds like a weird thing to do, but the reason for it is because the left side will always factor, and furthermore, the factors will always be the same. So the next thing, I'm trying to factor x squared minus 1 half x plus 1/16. Now I can get the factors right away. It's going to factor as x minus 1/4 times x minus 1/4. Again, the factors will be the same. So x minus 1/4 squared. By the way, it will always be the number that you're squaring in the previous line to get this number 1/16. So because I was squaring a negative 1/4 in the previous line, I'm going to have x minus 1/4 as the two factors. It's like I don't even have to think of it because I already know the answer, right? So then x minus 1/4 squared equals 3/2 plus 1/16. Well, 3/2 is the same as 24/16. 24/16 plus 1/16 would be 25/16. And the next thing is we're going to have to use this square root property. By the way, when you always learn the square root property before completing the square, because in the process of completing the square, you have to use the square root property. So I'm going to take the square root of both sides. And the square root of x minus 1/4 squared would be x minus 1/4 equals plus or minus, don't forget about that, the square root of 25/16. The square root of 25/16, that's the same thing as 5/4. Okay, so x minus 1/4 equals plus or minus 5/4. Now I'm solving this for x, so let's go ahead and add 1/4 to both sides. X is equal to 1/4 plus or minus 5/4. Well, 1/4 plus 5/4 would be 6/4. 6/4 reduces to 3/2. 1/4 minus 5/4 would be negative 4/4, or negative 1. Okay, so those two numbers would be the two solutions. Again, whenever I have a quadratic equation, I always have two solutions. So maybe the next thing you're wondering is, why in the world would I do the problem like this, where it factors, I get the same result, right? So I factored this and it took one line of work. Why would I take 8 lines of work here to get the same result? Okay, well, the reason for completing the square is not because of situations like this where we can easily factor and get the results. Okay, it's for situations where we can't factor. So maybe let me show you a better example of completing the square. Okay, because this one factored to begin with, so we could factor it and get the results, right? Let me show you a better example. What if I had this equation? I got 2x squared minus 1 equals 3x. I'm going to solve for x. Okay, let's go ahead and get everything onto the left. So 2x squared minus 3x minus 1 equals 0. If I try to see if this factors, let's see. Well, I got the factors of 2 are 2 and 1, so it'll be 2x and x. The factors of 1 are 1 and 1. That's a negative 1 at the end. So I know that the signs have to alternate, plus or minus. Is it going to be plus and minus? Well, let's see. If I check this, I got 2x times x, that's 2x squared. And then negative 2x plus x is negative x in the middle. That's no good. I need negative 3x in the middle. So what about if I switch the signs here? What if it goes minus plus? Okay, 2x times x is 2x squared. 2x minus x is x. I need a negative 3x. I'm not getting that. So I'm not seeing how this is factoring, right? And I've tried out all the possibilities. Nothing is working. Okay, which means at this point, the next best option would be to complete the square. Okay, so here's where we're at. Okay, now when you complete the square, again, there's two things that always have to happen before you complete the square. You need a 1 in front of x squared, and you need to bring the constant over to the right. Right now I've got a 2 in front of x squared, so I'm going to have to divide both sides by 2. And dividing both sides by 2, like I sometimes create fractions, that's okay. That it has to be where you have a 1 in front of x squared in order to begin. That's step 1. Okay, so I've got x squared minus 3/2 x minus 1/2 equals 0. The next thing is I'm going to bring the 1/2 over to the right. So I got x squared minus 3/2 x equals 1/2. Okay, and now I'm all set up to complete the square. So I'm supposed to take half of the number in front of x squared. I'm going to add that new number to both sides. Okay, well, in this problem here, I've got a negative 3/2 in front of x. I need half of that number, which is negative 3/4, squared. Negative 3/4 squared gives me 9/16. So 9/16 is going to be the magical number that we'll add to both sides on the next line. Okay? Now the reason for doing that is because the left side will always factor and the factors are always going to be the same. So now I'm trying to factor the left side. I got some fractions here, so what? I already know the answer. It's going to factor as x minus 3/4 times x minus 3/4. The reason I know that is because I was squaring a negative 3/4 to get this 9/16. And it's always going to be the number that you're squaring in the previous line. Okay, so it's like I don't even have to think of it. Okay, I got x minus 3/4 squared. And that is equal to 1/2 plus 9/16. 1/2 is the same as 8/16. 8/16 plus 9/16 is 17/16. And now I'm ready to use the square root property. So if I take the square root of both sides in that equation, the square root of x minus 3/4 squared would be x minus 3/4. And that's equal to plus or minus the square root of 17/16. The square root of 16 is 4. Okay, and then the next thing would be to add 3/4 to both sides. So x is 3/4 plus or minus the square root of 17/4. Or if I write that as a single fraction, I got x equals 3 plus or minus the square root of 17 all over 4. Okay, now just to make a note, let me come back to this line here. I was trying to see if this factored, and I was not getting very far. The reason I was not seeing the factors is because these nasty numbers here are the factors. And these are not natural numbers that I would guess and check with, if I'm trying to factor. Okay? So, in other words, the way that we did the problem, that is the best way to do the problem. Okay? That's the only way to do the problem at this point. We'll take a look at another example, and we'll save it for the next video, just for some more practice on completing the square. And so we'll go ahead and stop the video right there, and we'll pick up with this one here in the next video.